Hi, so today I'll be walking you through static analysis testing, and the tool we use is Spotbox. So first, what is static analysis? Static analysis is a way of examining code without actually running it. So it happens at compile time, not runtime. This technique helps us catch bugs early. So for things like null pointer risks, unreachable code, bad practices, and performance issues, by spotting these before we run the code, we save time, effort, and potentially big headache later. So, most importantly, what is Spotbox? So, it's an open source static analysis tool for Java. It scans the compiled bytecode, not just your source code, and checks it against over 200 known bug patterns. So, these bugs are categorized by severity: scariest, then scary, then troubling, then of concern. So it looks for logic errors, bad performance, potential security issues, and more. It's a powerful tool that integrates well with IDEs. One of them is IntelliJ. Now, how to install it? How to install Spotbox? So let me show you how simple it is. First, you open the IntelliJ IDE app, and then go to the top menu, File, then Settings, or Preferences. So in the left sidebar, click Plugins here. Then in the Marketplace tab, here, search for Spotbox. Then you find it, click Install, and once it's done, restart IntelliJ. And that's it. Spotbox is now ready to analyze your project for bugs. Or alternatively, you can also download it. From their website, the actual website, and it will be like a standalone tool. So, finally, what did we analyze? Our project was a simple student management system with student class for student info, student manager to store and check for duplicates, and the main to run the app. So this is my part, and my teammate will walk you through the code itself and demonstrate how we ran the tests using Spotbox.
In this video, I will walk you through our static code analysis using Spotbug on our basic Java student management system. This system has three classes: student, hold student information such as name, link, age, status, and some method to get the data. And also we have student manager, which is manage a list of student and operation on them, such as add to a list and get all student and check if the email is used or not. And we have also the main, which is test the application by creating student object and interacting with the manager. Now I already compiled the code using this command, as you see here, and then I update the Spotbug HTML so we can see the report with the bugs that we have. So as you see here, we have 6 bugs. 3 of them in the main page, 2 of them in the student, and 1 of them in the manager, with different category between site, correctness, performance, bad practice, and different level of the priorities, as you see. And it's also show the line that where is the bugs is it. And when you wanted to get more detail about the bugs, so you can come here and read, get more detail about it. Okay, now let's go back to our code and try to fix the bugs that we have. So let's start with the first one. We will start in the main page. So did this store or local variables? The category is a style, and for example, okay. Yeah, so as you see here, so I have Boolean variable called use, but it doesn't use. So Spot bugs report this as the store, meaning that the variable is assigned but not never used, often left over for development. So how we can solve it? Even like remove it, or we can like just system.out.print use. So even remove it, or system.out, so we can use it. Okay. The second one also in the main page, which is null pointer difference. So which is here, so it's always null. So how we can fix it? We have 2 ways to fix it. Either like, for example, do it like this, check if it's null, or but it will be always null. So the best solution is try to assign just any value for it. Just for now, like I will assign test, and it will check test dot string. So yeah, it will fix it. The third error is it an useless object create. Category is a style. So because the main class doesn't retain anything, or system out anything, doesn't give anything, so the spot bug report this as an useless void method. But because now we already add some system out, so it will be solved. Okay, so the bugs for is in student class, which is performance, and read field, which is here age. So I already have the variable age, but I never use. So how we can solve it? By add just a simple method, which is retain the age. So here, so yeah, now we solve it for this one. And the 5 bugs also in a student, which is unread field status. So as you see, like it is like string status, so it can access by anywhere. So this is will make a problem in encapsulation. So to solve this, we have to make it a private. And now if we keep it like that, it will give another bug, which is an unused private field, such as age. So how we solve it? Just by add another method called a status, and it is string, sorry, and it will retain a status. Okay, the final bugs, which is bugs number 6, it is in student manager. We have two bugs. The first one, which is bad practice. So here we're using double equal to compare between two objects, but it's bad to use because it's compare the object reference, not the object content. Okay, so how we can fix it? So we can use dot equal. So by using equal, we compare the content of each object, not the type of the object. And the last bug, which is I have the functions, but have no implementation. So how we can fix it? By either delete it if I don't need it, or like just add any implementation to it. Now I have tried to compile my code. Okay, and then try to update the spot bug report. Okay, so now let's try to give it and run it. So as you see here, we fixed all bugs with different category, different priority.
In this section, I will go over the fixes we applied using spot bugs, some challenges we encountered, and key reflections from the experience. So we addressed 6 issues spot bugs flagged, added a getter for the unused age field, made the status field private for proper encapsulation, replaced the double equal with dot equal method for accurate string comparison, returned a cloned array in get all students to protect internal data, added a simple print statement in the empty finalize method, and replaced a null assignment with a real string to avoid crash. One challenge was understanding the unused field warning. We fixed it with a getter. Another was string comparison using double equal, which we initially thought was fine, but research showed dot equal method is the correct approach. We also debated what to do with the deprecated finalize method and chose to keep it minimal. Lastly, interpreting some spot bugs reports took time because they were not always easy and clear to understand. For reflection question 1, static analysis checks code without executing it. Spot bugs scans Java bytecode and highlights bugs based on known patterns. This helps developer find and fix issues early, which is cheaper and more efficient than runtime debugging. For reflection question 2, spot bugs found performance and style issues, incorrect string logic, exposed internals, and a null pointer risk. This covered categories like bad practice, correctness, and potential security concerns. For reflection question 3, to fix them, we followed Spotbug's suggestions, used proper methods, added access modifiers, and rewrote risky code. After each fix, we rerun the tool to confirm the problem was resolved. And for the fourth and last reflection question, we learned a lot from Spotbugs. It showed how small issues can turn into real bugs, and we also gained confidence using static analysis tools and writing cleaner, safer Java code. And thank you for watching.